For our last section in stoichiometry, we're going to learn about limiting reactants and reactants in excess. We're now going to go over the concrete way of how to do the s'mores lab that we did yesterday. So generally, a reaction will have one or more reactants that are in excess, meaning we have some leftovers. And the reaction will proceed until one of the reactants is all used up. Now, the limiting reactants limits the extent of the reaction and thereby determines the amount of product formed. We can't make more product than we have the ingredients or the reactants for. That means the reactants left over when a reaction stops are called the excess reactants. We can think of excess reactants as the leftovers. Determining the limiting reactant is important because the amount of product formed depends upon that reactant. If we don't know the limiting reactant, we don't really know how much product is going to be formed. Thinking about limiting reactants and reactants in excess in terms of food is an easier way to think about it just because it's something relatable to us. However, the process is no different than when we're using an actual equation in chemistry. So let's say that we had 2 slices of bread, 3 pieces of meat, and 1 slice of cheese, and this equals 1 sandwich. If we have 6 slices of bread, then we could make 3 sandwiches. 12 pieces of meat, we could make 4 sandwiches. 5 slices of cheese, we could make 5 sandwiches. Since we're limited by the amount of bread, we don't have enough to make any more than 3 sandwiches. It becomes our limiting reactant. So we make our 3 sandwiches, and then we're going to see what's left over. Well, we'd have 3 extra pieces of meat left, and we would have 2 extra pieces of cheese. Now, while we were able to do this all in our head just with some basic reasoning, really what we're doing here with the 2, the 3, and the 1, those are really just mole ratios. So when we have an equation with mole ratios, we're doing the same thing. We're dividing to figure out how much is going to be left. To find the limiting reactant when we're working with substances we're not used to, first we need to make sure we have a balanced chemical equation. If it's not balanced, then we don't have the proper mole ratios that we're going to need to do stoichiometry. Second, we're going to find the desired amount of product made from each of the reactants. So if we have 3 reactants, we have to turn them into the product of interest. Then the reactant that yields the least amount of the desired product is going to be our limiting reactant. We can only make as much as our smallest amount. Then the amount of the product made is the amount formed from the limiting reactant. If 200 grams of sulfur reacts with 300 grams of chlorine, what mass of disulfur dichloride is produced? And we have the following chemical equation right here that gives us the relationship between our reactants and products. What is the limiting reactant? What is the reactant in excess? And we also have the molar masses right here. So if we want to find the amount of our product, we actually are going to have to go from the first reactant into the product. And we're going to have to go from our second reactant into the product. Then whichever one makes the least amount, that's the actual amount of the product made. I'm going to label the sulfur as A, the chlorine as B, and the product as C, just so I don't have to keep rewriting their formulas all over. And let's start with our first one. We're going to turn sulfur into our product. We're starting off with grams of sulfur. So 200 grams of A. And we want to know the mass of the disulfur dichloride, the mass of our product. So we're going to be going from grams A all the way into grams B on our mole map. So first we're going to have to use our molar mass. So grams of A into moles of A. Then we're going to use our mole ratio, where moles of A is on bottom and moles of C is on top, since we're wanting to find the amount of product. Then we're going to do molar mass again, where we're going to go moles of C into grams of C. Now we can put our values in. The molar mass of A is given right here. 256.48 grams are in 1 mole. Our mole ratio is going to come from the balanced chemical equation. So we have a 1 here in front of the sulfur, and we have a 4 in our disulfur dichloride. Then the molar mass of disulfur dichloride is right here. So 1 mole of disulfur dichloride is 135.02 grams. We'll multiply and do all of our math, and we're going to end up with 421.1 grams of disulfur dichloride. Next, we're going to have to repeat this process, but we're going to have to go from our grams of chlorine, again, into our grams of product. And we're starting off with 300 grams of chlorine. And chlorine is B. So, same steps. We're going to do molar mass. So, moles of B over grams of B. Then we have a mole ratio. Moles of B on bottom to cancel. Moles of C on top. Then molar mass again. Moles of C on bottom into grams of C. Whoops. And we'll put in all the appropriate values. The molar mass for chlorine is given here. So 1 mole is 70.9 grams. Mole ratio, 4 of chlorine and 4 of sulfur dichloride. And the molar mass of sulfur dichloride is still 1 mole, is 135.02 grams. We'll go ahead and do the math, and we'll end up with 571.3 grams of disulfur dichloride. Now let's get to this question. What is the limiting reactant? Well, remember, the limiting reactant is the one that produces the least amount of product. So we produce the least amount of product right here. And this all came from when we used A. And remember, A was sulfur. So our limiting reactant is going to be sulfur. What is the reactant in excess? Well, that is then going to be our chlorine equals our excess, because we are going to have some of it left over. So lastly, what is the mass of the disulfur dichloride produced? We can only make as much as our smallest amount. So that means the 421.1 grams, that is the actual amount of product that's going to be made when we react the 200 grams of sulfur and the 300 grams of chlorine. Now that we know the amount made in a reaction is going to be the smallest amount of product formed, and that substance is our limiting reactant, every other reactant becomes the excess reactant. And let's say we want to know how much reactant was left in excess. Well, first we are going to have to find the limiting reactant and just know what reactant is in excess. Then we can find the mass that we used of that reactant. In order to do so, we're going to convert the amount of the product that was made to the desired unit of the reactant in excess. If your reactant in excess is in moles, then convert to moles. If it's in grams, do grams. Then we're going to subtract the starting mass from the mass used, and that's going to tell us the mass that is left over. Let's look at an example. If 25 grams of phosphorus and 55 grams of oxygen are combined, first we want to know what is the limiting reactant. In order to do that, we need to take the mass of each reactant and turn it into the amount made of the product. So let's start off with our phosphorus. I'm going to call that A, oxygen B, and the product C. So we have 25.0 grams of A. We are going to go and do our molar mass. So we're going to have grams of A on bottom over moles of A on top. And we're going to then do mole ratio, so moles of A on bottom and moles of C on top. Then we'll put our values in. 124 grams of A is 1 mole, and our mole ratio appears to be 1 to 1. However, we should check and make sure that this equation is balanced. We have 4 phosphorus, 2 oxygen, and 10 oxygen. That doesn't cut it. So we're going to need to put a 5 in front of the oxygen on the reactant side in order for it to balance out. However, that's not going to change our mole ratio here between phosphorus and the product. So it's going to be 1 to 1. We'll go ahead and do the math, and we're going to get 0.202 moles of C are formed. I'm stopping here in moles because it didn't ask how much product was made, so that means we could really go into whatever unit we want to, and if we stop at moles, that just saves us a step. Now we're going to repeat this process with our 50 grams of B. Again, molar mass, so grams of B under moles of B. Then mole ratio, moles of B on bottom and moles of C on top. The molar mass for B is 32 grams in 1 mole. And our mole ratio is 5 of B in 1 of C. This comes out to 0.313 moles of C, or our product. So, if we want to find our limiting reactant, we have to see which reactant made the least amount of product. And the least amount of product came when we were using A, which was phosphorus. So our limiting reactant is going to be P4. That means our excess reactant is B, which was oxygen. So our limiting reactant is P4, and our excess reactant is O2. Now for part C, this is the new stuff. How much of the excess reactant remains after the reaction? So we need to say, if we actually make 2.2 moles of C, how many grams of B did it take to do that? So we're going to start with the amount of product actually made. So 0.202 moles of C. And we're going to turn this back into grams of B, or our oxygen. So mole ratio, mole of C on bottom to cancel out, into moles of B. Then we'll have moles of B on bottom to cancel out, into grams of B. Our mole ratio, 1C, is 4 Bs. And molar mass, 1 mole of B, is 32 grams of B. We'll go ahead and do our math, and we're going to get 32.3 grams of B. But again, what exactly did we find here? We found the amount of B that was used. This is how much we had to have in the reaction in order to make this specific amount of product. So if we think about this like baking, we had to have 32.3 tablespoons of B if we wanted to make 0.2 moles of whatever it was we were making. So if we want to find what's left over, since that's what the question's asking for, how much was in excess, we're going to have to take our original minus our used. We start off with 50 grams. We used 32.3 grams. That's going to come out to 17.7 grams that is left over of our oxygen. That's how much oxygen is in excess. In these kinds of problems, we're really just doing stoichiometry a couple of different times. The most important thing is to know, what are we finding as the result of doing our stoichiometry? So it might be helpful to add a couple of extra labels and maybe label things as this is what is made, this is what is used, this is what is left over. Because we can keep track of not only the unit, but what it represents. That helps us better make sense of what's going on in the problem.